The title of this video is Prismatic Effect of Lenses. Lenses are formed of indefinite number of prisms of gradually increasing power from center to the periphery. Convex lenses can be thought of as indefinite number of prisms base to base, while concave lenses are arranged apex to apex. Notice that the prisms are of gradually increasing power as we go from the center to the periphery. That's to say, the strongest prism is in the periphery, while the weakest is central. At the optical center, there is no prismatic effect. A lens is formed of indefinite number of prisms. The size of the individual prisms become individually small until eventually they merge into one another and form a curved surface. At the center of the lens, there is no prisms, only two parallel plates of glasses. As we go toward the edge of the lens, parts of the surface are parts of the prisms. The power of that prism is gradually increased as we go toward the periphery. Therefore, there is no prismatic effect at the optical center, while prismatic effect is maximum at the periphery. Keep in mind that a lens is not formed of two prisms. If you hold two prisms base to base, you have a biprism and not a lens. Each prism will shift rays toward its base, but rays will not be focused. Now I want you to watch this video. Draw a cross on a paper. I want you to compare the segment of the line seen through the glasses with the remaining part of the line. We do the movement in one direction, then the perpendicular direction. We can repeat this with another type of glasses. Prismatic effect is used to identify the type of the lens by watching the effect of the movement on part of the line seen through the lens. Here, this is the line drawn on a paper, and this is the unknown lens. In the lower part here, this is the line of sight between our eye and the line drawn on the paper. As you notice here, in the starting point, the line of sight is in the center of the lens. Now we make the movement in one direction, say downwards. In case of a plus lens, the portion of the line seen through the lens is moving against our movement. While in case of minus lenses, the portion of line seen is moving with our movement. Why is that? Initially, the line of sight is in the center where there is no prismatic effect. On moving the lens, eccentric parts of increasing prismatic power will be within the line of sight. The stronger the prismatic effect, the more the shift of the line. The direction of shift of the line varies between convex and concave lenses depending on the direction of the apices of these prisms. We repeat the movement vertically, then horizontally. When the speed and the direction of line shift is the same in both directions, then we are dealing with sphere. If we are dealing with a cylinder, the rapidity of movement or the direction of the movement will be different. This will be explained in details in another video. When an optician is manufacturing glasses, he or she aims at having the optical center of the lens in front of the patient's pupil. If that was not the case, patient will suffer of prismatic shift of the image while he is in the primary gaze. The amount of shift of the image depends on the distance between the pupil and the center of the lens and depends on the power of the lens. The more the decentration distance, the more the prismatic effect. The higher the lens power, the more the prismatic effect. In this example, this patient will suffer maximum because the prismatic effect in one side differs from that on the second side. So I end this talk by the Prentiss Rule. Prentiss Rule determines how much deviation you get by looking off center of the lens. As we said, there is no prismatic power at the optical center of the lens. The deviation in prism diopters depends on the distance of decentration from this pupil to the optical center and depends on the power of the lens. Thank you for your attention.